Okay, we should get started. So, well, at least you guys made it after the last night festivities to talk more Hadoop, which is good. Um, the motivation behind this talk is to really put years of perspectives we have had running Hadoop at scale and talk about very concrete points in terms of what it scales, what it takes to scale Hadoop, and where should the emphasis be when you're starting your journey with Hadoop, or at least starting your journey seriously scaling Hadoop. Right, so before we begin, let me introduce myself. My name is Sumit Singh, and I manage products for cloud and big data platforms at Yahoo. My co-speaker is Rajiv Chetajalu. He's been with Hadoop operations since day one. So we've put together a lot of these perspectives or learning that we've had over years. So I sincerely hope that you'll find this useful. So before we begin, let me put the context of what the role Hadoop plays at Yahoo. So our products and properties, and we have a lot of those, generate immense amount of data that is of value to us. But at the same time, we want to capture that data in an economical fashion, and that's where Hadoop started. So billions of events actually land every day on the Hadoop grid, and the idea is to create a common shared platform which is multi-tenant for the entire company to use. We also pull data from a variety of third-party sources, be it web crawl content or social data or other types of data, and they also land up on the same Hadoop grid, right? So then we process that data and apply the insights that we get from that data back in our business, be it in the form of content personalization or advertising, in particular ad targeting or campaign management for our advertisers, or data itself, right? So just supplementing the products and properties we have. And of course, you could run reporting, analytics, or do BI on top of that processed data, right? So that's the context of Hadoop at Yahoo. And bringing all that data together on a common platform gives us a lot of leeway in terms of sharing and enriching data across the company. And then as a result of bringing all that data in a common place, as you will see, we started to scale the platform over the years, and it has scaled pretty well for us. So we're at a point where we're roughly running 43,000 servers for Hadoop, 3,000 for Hbase, and 2,000 for Storm. So give and take, it's about 50,000 servers that we're running together on this aggregated platform. And this talk is really about what it takes to get there. So what we've done is that we brainstormed ourselves, and we said quickly, though, not a lot of time, but we said, what are the top 10 things we want to talk about when it comes to running Hadoop as a business, as a hosted service for the company at scale? So the first consideration, of course, is that where do you want to run, right? Be it on-premise or public cloud. So I think that's the primary consideration you would go if you're starting fresh. The second important thing that gets often overlooked is what would be your total cost of ownership in either of those models, and then how do you drive business decisions based on that total cost of ownership. Then the third question we get often asked is that, is there something special that you run from a hardware perspective, the configuration itself? So we will talk about that, how we think about hardware configurations. Network is also often an overlooked component in the overall ecosystem. So we'll talk about network at depth. How do we think about what it costs us to connect a server to the network, so it's dollar per server, and how do we think about optimizing both for that as well as latency, okay? And then again, the goal there is to have a consistent performance both for inter-cluster or intra-cluster transfer. We'll definitely touch upon the software stack and how we think about the various components in the Hadoop ecosystem, because that's also crucial given the number of projects we have out there. Security and account management is a huge area, so we will dive deeper into how we think about security and have set things up that allows us to scale. Data lifecycle management as well as BCP provisions is, of course, important because it's all about data. So we'll touch upon that. We'll also talk about metering. That allows you to do chargebacks or other things, audit and governance, because those are also crucial. We as an internet company have to comply with certain requirements. And then we'll talk about how this platform integrates with both internal systems that Yahoo has in other parts of our business, as well as external systems, be it some of the companies we acquire or in other ways, like our partners and other stuff, and how does that sort of integrate with this platform? Because I think that's also quite important. And finally, we want to debunk some myths that are around in terms of what Hadoop is not. And I think that should be straightforward. So that's what we're going to talk about. So we'll start with the deployment model itself, right? The first question you would ask is, where do you go run? Is it public cloud, or should you set up your own infrastructure? So if you go about setting up your own infrastructure, I think there are two predominant models there. One is what we call as dedicated private clusters. So these are either built for really demanding use cases when the use case itself is really large, or it's built for experimentation, or there are other reasons around it. But that's a viable sort of model or setup that people have, and you can operate multiple clusters for multiple use cases. The other, which is the predominant model, the model we follow, is that you host a number of tenants on the same cluster, a number of use cases which are very diverse, both from a data standpoint as well as what they do with that data standpoint, right? So you bring all the people together on the same cluster, and you don't really distinguish between one cluster versus the other. So they all come to follow a common philosophy, right? So that allows us to save cost tremendously. And of course, these two, whether it's dedicated or shared cluster, they share data, right? So that's given. The other model is the public cloud model. Now, in public cloud model also, there are two sort of dominant themes. One is where you get dedicated compute instances, launch Hadoop on it or run Hadoop on it, right? So that's quite popular, and a lot of people do that to save time. The other sort of model in public cloud that is getting popular is what we call as purpose-built big data cloud. And over here, I think the real pitch or the value proposition is that there's a lot tighter integration with different stack components of the big data technology stack that the cloud provider offers. And there's a lot of value-added services on top of that. So, and that's getting quite popular because of that tighter integration, be it for performance reasons or for offering other value-added services on top, not just compute and storage. Okay. So where should you go? I don't think there is any hard and fast rule, but there are certain things you should consider in terms of where you should go. And one of the first considerations that come to people's mind is cost. So we'll touch upon cost, and I would think about cost in a variety of sort of forms throughout this presentation. But cost is critical, so what it costs for you to set up an on-premise infrastructure versus going in the cloud, both now and over a period of time. You should think about that because the cost characteristics are quite different. Data is another important aspect as to where the data is generated and stored. So if it's generated and stored in cloud, maybe you should just run Hadoop there versus sort of being on-premise because data has inertia. Once it goes at rest, it's really hard to move data around. SLAs are another important factor that you would consider keeping things on-premise versus going on cloud because the guarantees that what a cloud provider would provide may be different than the guarantees your customers would expect when you run the platform on-premise. Tech stack itself is also important because Hadoop may be a part of your overall infrastructure or data architecture, and there may be other things. So if you need integration in certain ways, I think that becomes an important consideration, the control itself that you exercise over the tech stack. Security is another important aspect. The only thing I would highlight here is that contrary to sort of popular belief that security isn't a big deal on-premise, and it's only a big deal on public cloud, I think security becomes a lot serious of a deal on shared multi-tenant clusters because you're landing all of company's data in a common place, but you still want to govern that data really, really carefully. So security becomes hard because there are all kinds of tenants on the same platform operating on the same data, and you want to control that really carefully. And then multi-tenancy, of course, it's hard. So you have to consider whether you go with a shared multi-tenant cluster or private dedicated clusters. Because in public cloud, most often than not, you would spin up your VMs over a cluster which is dedicated for your use. No one else is sharing it. And as I said, there is no hard and fast rule. A single criteria may sway you in one way or the other. Cost and SLAs are something you could evaluate quantitatively, and rest are sort of more qualitative. So you just have to think through these and figure out which one makes sense for us. And that's what I'm showing here, is that it's really easy to go one way or the other based on just a single criteria, and you don't really have to think about the others. Utilization, as I said, is a real big deal. So utilization follows very different cost characteristics. In an on-premise, it really looks like a step function. Every time you add hardware, scale the infrastructure, the cost goes up vertically, and then it stays flat again, versus a public cloud where it's more of a pay-as-you-use model and tiered prices kick in or term-type pricing kick in. But there may be crossover points based on when you scale, and the utilization of that scale. There will be crossover points where on-premise infrastructure will become cheaper or may become cheaper. So again, thinking about the future is really important, or do a sensitivity analysis on what other do you expect this infrastructure to do. And I think that will give you a much more clear answer from a cost standpoint. Okay, that's what I'm saying. So at a certain point, I'll favor the on-premise infrastructure. At a certain point, I'll favor public cloud. The second aspect is to think about TCO, because not a lot of people do this exercise, and I think this is really important because it will allow you to drive business decisions in a much more meaningful fashion. It's something that is backed by data. Okay? So there are several components that go into this TCO model, or a model that you would develop, the first being hardware itself. And I'm not just talking about name node or data node, I'm talking about all kinds of other hardware that go around the infrastructure, proxies, gateways, things like that. So you aggregate the hardware cost of the entire infrastructure. You also need to think about the R&D headcount if you're going on the platform or setting up a platform in a big way, because that could be substantial. You have to think about the active use and operations costs. So a lot of this is just about the data center cost, which is power, space, cooling, things like that, right? So you have to aggregate all that cost together. Network hardware can be substantial, and we'll talk a lot about that. So that you have to also account for in the data center itself. And when you're setting up an on-premise infrastructure, there is a lot of acquisition and install cost involved. So do not ignore that, actually include that. Even though they're one-time costs, there will be operations headcount costs associated with running that service across your company, as well as if you have multiple data centers or you have data transfers in and out of your data centers, there will be substantial bandwidth costs, and that can be big depending on how you're set up. So do not ignore that either. What this would give you is an aggregate cost view of running that infrastructure, right? So you could take all that cost, do appropriate depreciation on the hardware and other things, and arrive to some monthly equivalent cost of running that infrastructure, right? Either today and tomorrow. Then you have to sort of measure the usage. So if you're setting up a project that requires X amount of capital, you have to measure what that project will consume to get to that X amount of capital, so that you can make a good decision whether that project will give you a good ROI or not, and whether it's a viable project for Hadoop or not. So you measure 3 or 4 things from a Hadoop infrastructure standpoint. Compute, which is generally memory and CPU. So with Hadoop 2.6, 2.5, I think 2.6, you will get both memory and CPU. So Jan would control both memory and CPU. And the notion we follow is GB hour, and for CPU, it's week or hour. So you just need to know that and allocate a portion of your monthly TCO to compute. Same goes for storage as well as bandwidth. So you have to allocate a certain portion of your TCO, which is storage driven, to storage, and it's really simply $1 per GB of data stored. And for bandwidth, it's the aggregate in and out of clusters, so $1 per GB of data you're transferring in and out of the clusters, right? So straightforward in terms of thinking about resources. We also think about namespace on the name node really seriously because of the limits that we're put As your clusters scale, you will start to feel that pressure on your name node in terms of aggregate namespace that the name node can manage. So we also manage that as a commodity, and it may or may not be applicable to you. So we kind of think about splitting. So since we buy servers as JBODs with compute, what we think about is splitting that cost 50-50 between compute and storage. And then for compute, we do 25-25 on an average between memory and CPU. And on the storage side, we would do 25-25 for disk and namespace, right? Again, you could tweak that weight based on your situation and how you configure your hardware or buy your hardware. And then measuring consumption is really straightforward. It's actually getting easier. So this was the way we would do that with MapReduce before, where we take the map and reduce sizes, the container sizes that Jan would allocate for your tasks, and then multiply that by the time the container was allocated for your job, and then sum all that up. Now it's actually a lot more simpler. With our map summary, you can just get an aggregate metric of memory seconds or CPU, vCore seconds, and that's essentially your compute consumption for the job. And then you can roll the jobs back up by user, by project, by BU, whichever way you think is appropriate for you to set up the TCO model. Okay, storage is the same way. It's actually even more straightforward. It's just the storage that you use, the disk you use. And then bandwidth, you could choose to include it or ignore it. It's really hard to measure it per job or per customer. Generally, it's on a cluster aggregate basis, so you could just split that. Assume you're splitting that since it's part of your TCO across all your customers, right? With that, let me hand it over to Rajiv, who has deep operational experience. I've said he's operated the Hadoop cluster since day one, since 2006, to give you some perspectives on hardware, security, and network.
Thank you, Sumit. So in continuation with what Sumit has just covered, once you start deciding what kind of size of the cluster you want to run. So a typical layout of your cluster would be you have a set of racks. They have on top of the rack switch, and on top you have an aggregation layer of your network. The total bandwidth, you can look at what is coming in and out of the cluster that could remain within your data center or leaving your data center. Each server has CPU, memory, and storage disk. So here we're primarily focused on a JBOD kind of configuration. We still feel that keeping storage and compute together would give you a best value of it rather than splitting them out and vertically scaling. So the hardware configurations over our course of years at Yahoo, we varied a lot. We started in 2006, 2007. We started with Harpatons, and now we are running with Haswells, right? So if you see, the memory has grown in a certain set of multiples, but the CPU, the number of cores per CPU is changing, and the variety of options you have at CPU level is so wide. Like Ivy Bridge and Haswells, you can go from 12 cores to 30 to 48 cores, right? And so the balance between the memory to a core is typically to how your application runs. Like Spark might consume more CPU, you can natively parallelize within your executor. MapReduce would still remain within a specific core and a set of memory sizes. Storage, the density of storage is constantly growing, and the current standard is 6 terabytes. There's no reason why you shouldn't buy a 6 terabyte drive now. And the number of drives per node really is dependent on how much data you wanted to store. There are hardware options that are available. You can go with a really fat node, like more than 12 to 24, but you also want to consider, right, the whole concept of Hadoop is running it on a commodity hardware. So commodity hardware is expected to fail. So try to limit your failure point to a smaller footprint that can be manageable in the cluster. If you have a really wide, like 4,000 node cluster, the failure point grows across a set of racks, not a node. But if you have a smaller cluster size, the failure point remains within a node, Right? If you lose a node with the 24 spindles, you lose a lot of storage. As I mentioned, there can be various combinations of hardware, of storage to memory ratio that is available. The sweet spot would be not go extreme on either end, not go with 256 gigs of memory and like 4 by 6 terabyte drives, right? So for company, so we have seen a transition in terms of we started with like a half a terabyte to a terabyte drive of 4 spindles. And during the course of certain years where most of all the data pipelines are moving into Hadoop, that's where our Hadoop expansion has gone up since 0.20 release. So we've seen all the data moving from the warehouses into Hadoop and then applications running on it. So there was a huge demand at one point on storage. So at the time, it made sense for us for cost perspective to buy more spindles. But as we progressed forward, so the drive sizes has increased. When you move to a 4 terabyte or 6 terabyte drives, the amount of storage on a 12 terabyte node, 12 drive node is getting really big. Same with the storage, same with the compute. So trying to limit to a reasonable size. So you might see the similar transition that when you want to start a Hadoop cluster migrating from a traditional warehouses, you might see the growth of storage, so you might want to consider buying a 12 spindle node. Network is one critical component of your clustered infrastructure. So you have various services, and most of the services you would co-locate so that they can consume data among each of them. So you could have a Storm topology reading your models with point lookups from Hbase. The models are actually built on a MapReduce job, writing onto Hbase, and Storm can write back onto HDFS as well. So over the course of this conference, you have seen various applications, each one interacting together. So that is really possible because they all remain in a common network backplane. And you want to look at building your network layer that would support all these various services. So the compute node component in all these would generally remain the same. You want to consider choosing the same node configuration so that between Storm versus Hbase versus Hadoop, HDFS, to be closer so that you can interchange applications. Yarn really helps in this case, like if you want to run Storm on Yarn or MapReduce or Spark on Yarn, right? You can interchange. So scheduler really matters. Yeah, the network case, so the Storm might be a bit latency sensitive, but the rest of the Hadoop applications are really many to one, right? So it's more than latency, you need raw bandwidth throughput. So you build your network as fat as possible with as much uplink as possible. If you are within the Hadoop cluster, the shuffle phase, which consumes majority of your traffic, so the data would remain within your set of racks of your Hadoop cluster. Hbase, you might be publishing your end result of your model, for example, into Hbase so that you can do real-time lookups of your models, or run Phoenix, for example, to do SQL-based queries. So if you have a real-time pipeline, like in a Lambda architecture, you are doing a MapReduce pipeline for your whole large set aggregations, but you're running minute-by-minute reporting running through Storm, it might be consuming within the same cluster. As well, Storm can write back onto Hadoop as well. So this is slightly previous generation architecture, because at this point, if you're building a new cluster, you want to consider a 1 gig network, because 10 gig has become base commodity. But so this architecture, like you have a big aggregation switch at top level that aggregates all your rack switches, and and the rack switches in turn would connect your compute nodes. So this is a typical, you have a chassis switch versus top of the rack switch. This kind of separation, the the subscription levels would remain the same. Each node would connect at 1 gig to your top of the rack switch. Your top of the rack switch would probably have like 2 by 10 gig into your BAS layer. And if you have multiple BAS layers, you want to do a fab layer so that you can aggregate across. So above your rack switch between two rack switches, it's a full all-to-all bandwidth that is available. The choice of how much oversubscription you want to require is dependent on how many uplinks you wanted to do between your rack switch and your BAS layer. So typically 1:2 oversubscription should be easily possible with a very sweet price point. So as you see, the rack switch is at 10 gig, rack switch to the BAS is 10 gig, and to keep everything consistent, you want to increase the links between your fab and your BAS in the same ratio. So this would give you an all-to-all bandwidth above your rack switch. So in this typical setup, you could have around close to 15,000 switches. So this 50,000 hosts. So this is wide enough for both your MapReduce and Storm and Hbase running together. Still, rack switch is a single point of your failure, but if you have a wide enough environment, your whole cluster could survive easily. So this is the next generation of network designs that's being adopted across various environments. This actually started from the original telecom switching in 50s. You see a similar connectivity diagrams around there. So here it's what Beowulf did for Linux clustering. This is what is happening at the network layer. You take a typical commodity rack switch and you build your backplane with the same hardware. So your rack switch and your rack layout would remain the same, but your network is now clustered. So you use the same typical rack switch to build your core by a two-level design called leaf and spine. So a typical switch in this case would be a 64-port 10 gig. So the number of links that go from your rack switch, or what you call as the top of the rack in some cases, would define how many leaves and spine you have. So basically, if you have 16 spine switches, you can fan that out into 32 leaves, and 32 leaves would fan out to 32 rack switches. So each node would connect to the rack switch at 10 gig, and you have 80 gig. In this case, you have 80 gig uplinks with 2 virtual chassis, 40 gigs going into each of the virtual chassis. Here, with 2 virtual chassis, you have 5:1 oversubscription for a 10 gig link. With 16 spines, 32 leaves, you have 2 by 40 gig. You will get 80 gig uplinks, 512 rack in overall. This is a typical design for a 20K wide network layout. So you can add more virtual chassis. So you can upgrade this to 160 gigs. Still, your top of the rack switch is a failure point. That's why you want to consider how fat your nodes should be within a rack. Putting it all together, we covered what kind of process you wanted to have, and your what kind of storage, and about power supplies. Do you want to go with dual power for every rack? We don't think that is really necessary, since the whole entire core of Hadoop is running on commodity hardware, so it should take failures and replicate your data. So as long as you don't build a really fat node, you don't need redundant power supplies. 10 gig is literally now you're getting it on board. So now coming down to the software stack. This is a typical software stack we run. So you have your monitoring underneath it, and your how you bootstrap your node. On top of you run Hbase and HDFS. You have your compute layer, and you have various services running on top of it. The choice of software stack is you should just look at the use case you want and pick the right software stack that is required. The core still remains the same. You have HDFS and Yarn. Even though we don't see a lot of people talking about HDFS, but if you look at the entire stack of Hadoop applications, HDFS is still the core, right? And you need a scheduling layer so that you can use entire Hadoop and all your compute nodes. You could run Storm, you could run various application layers, and beyond that, it's up to your applications and what kind of support you get to the rest of the platform. Right? There are various solutions around it, and Apache Slider is one with which you can run any kind of generic application very easily on Yarn. Now, once you do the multi-tenant clusters, security becomes really critical. Like how do you identify and distinguish multiple users within your cluster so that you can differentiate, segregate the resources accordingly. So all the Hadoop applications supports Kerberos at this point, and you have a single user ID per application. You can do a single sign-on, and you do groups to roles mapping. That's where you control who has access to resources. All the RPC is protected, and the UI with HTTP SP-Nego authentication. Putting it all together, you can choose most of the single sign-on providers like Active Directory or one of the single sign-on solutions from Oracle. Underneath, in turn, they support Kerberos. So Kerberos has been used across distributed systems for like tens of years, right? So that's the key that binds the rest, all the Hadoop stack together. And within the Hadoop stack, you have they issue tokens so that the identity remains consistent across various services. So talking about how you want to manage your data, I would like to hand it over to Sumit.
Thank you, Rajiv. So we will go fast. Data lifecycle management, irrespective of what tool you choose or have something homegrown, there are 4 or 5 functions you need to worry about. First is the acquisition of data. The second is replication of data, because oftentimes you would operate clusters in multi-data center type setup. You need to think about retention of that data and how to set retention policies, because that drives a lot of cost on your storage nodes. And then finally, archival, either because of compliance reasons or you want to because you want to save certain data in some sort of cold storage. So each of these lifecycle aspects have to be managed by some sort of a tool that you would use, right? So the way we think about data lifecycle management is that we have a set of acquisition sources where a tool which we use called GDM, Grid Data Management, acquires data onto our clusters. So the unit of acquisition is called dataset or feed. And that's where we move the data onto our Hadoop clusters. We also register the schema for that data in a metastore, which is hCatalog for us. So this tool is integrated with hCatalog. And then as the new sort of portions of that feed are acquired, either daily, hourly, or on a minute basis, whatever the case may be, those are partitions that are registered in hCatalog. So hCatalog, the metastore itself, supports adding partitions onto the created table. So all that partition addition is supported by our data lifecycle management tool. And that partition add can actually trigger event notifications for data availability for all downstream consumption. Okay? And that message could be consumed over any message bus, irrespective of, so it's JMS compliant, it depends on what you would use. We, in many cases, use ActiveMQ for that purposes. And then the same tool actually can make data available in other clusters as needed and would repeat the same process of registration as well as partition availability. And then again, downstream consumers who are dependent on the availability of that data gets notified by the JMS messages, right? So the whole thing is a lot more real time and doesn't require any intervention or knowledge of when the data comes in, when does it get available for processing. Almost all the processing waits on data availability. As they receive notification, they're JMS listeners, essentially. As they receive notification, they kick off their workflows. And then archival and retention are supported per data set. So you set policies per data set, and as policies expire, retention period expires, that data, the same tool deletes that data. The other topic which is really important when you're running at scale is metering, audit, and governance. So metering is quite simple. Hadoop logs are exceptionally rich, and you should never throw them away. So what we do is actually warehouse all the logs from various systems into a common Hive data warehouse. So as you can see, we pull these logs nightly into a common warehouse through an Uzi workflow that is running dist CP jobs across data centers and collecting all the raw logs in HDFS, and then we process that, put it in Hive or HCAT Metastore, and then it's available for ad hoc queries to figure out what is going on our platform. So that's how we do metering. That's how we figure out who's consuming what else is going on, who's opening what file. It's really rich, and you can get really, really granular in terms of what is happening on your platform. And then you can use a similar setup to actually do governance, which is the way we do it. So we register every data set in the Metastore, the schema for that data set. So the Metastore has the metadata for all our data. And it's not 100% yet, but we're getting close. So 40, 50% of all our data is reflected in the Metastore. So then we allow our users to discover data on various clusters through the same sort of setup where Web HCAT APIs are called to collect all the metadata information for across our data centers in one central place. So you get a global view of all data that's available in the company. And then you can govern the access to data and other types of things through the same portal. So we call it data discovery. And then we allow people to access data based on certain set of policies in terms of what that data is, right? So the governance policy is set for the data set. All that is accessed and controlled through a central place. And we're in the process of moving completely to this model. We're somewhere in between right now. But it's really helping. It's really helping both for governance as well as audits. Oh, and then you can apply a variety of business rules, like if one of our customers wanted people to have taken the governance training, data governance training, before they could allow access to their data sets. So we integrated with the SuccessFactors APIs that would check for governance course completion certificate, basically in the same approval flow. So all of it is automated, which is really cool. You don't really have to spend much time on that. And then since a lot of the acquisitions we've made in the internet space have also built their infrastructure on Hadoop, it becomes quite easy to then bring all that together in this platform. So the integration aspects of at least the acquisition side, which are the infrastructures in transition, as we call it, is easy. It's not hard. It's not that you had two separate companies, two separate infrastructure, and bringing that together will be really hard. It actually becomes a lot easier. A variety of tools we have developed around monitoring and other user portals, they all work really well seamlessly with Hadoop. The serving stores work really well, so NoSQL stores we have which are not Hadoop, like Sherpa and other things, they work really well with Hadoop. So NoSQL stores that we have, distributed NoSQL stores, object stores that are integrated into Hadoop. So you can bring data from those into Hadoop, do analytics, store results back. And then Hadoop also stores supports a very rich set of BI and analytics tool on top. Some of the ones we support, as you can see, MySQL, Tableau, MicroStrategy, Druid, Oracle, all kinds of things. And almost all of Yahoo sort of becomes a customer in a setup like this. Yahoo Mail, Finance, Advertising, Search, you name the business. Okay. And then a lot of people think about, Hadoop isn't quite ready. That's not true. I think it's very ready. It's quite stable. Clusters don't really go down with HA and rolling upgrades. And then some people think you may occasionally lose data on HDFS. We hear that a lot. It depends on what you're doing with it, right? So you don't, by itself, would lose data. So you have to be careful. Data can very easily be shared across organizations in your company, as we've shown in the security setup, if you're careful about how you put your security and governance around it. Name nodes scale, some of our name nodes have vertically scaled to support 600 million files, blocks, directories, so they have scaled fairly well to support clusters of at least 6,000 servers. Software upgrades are rare. I think we roll software every day, every other day. And I'm talking about core Hadoop. So things change and are always in fix, and it's fine. You can still continue with normal operations while keeping the software up to date And then I need expensive servers to get more. That's totally not true. I mean, you can go quite cheap. And then Hadoop's evolving. It's really not dead. A lot of people say, oh, we should move on to this and that. That's not really true. It's evolving, and it's evolving really rapidly. So I think these are all myths. And with that, I think we're out of time, but might take a couple of questions. And you have to go to the mic. No questions? OK, you have them.
I know we're almost out of time, but could you elaborate just a little bit more on your replication and archiving systems?
Sure. So replication is a normal process, right? So the tool provides the applications an ability to replicate data, and most applications would use that capability to set up a BCP environment for their application. So you would run your primary in one data center, your secondary or BCP in another data center, and both could run hot, where you're processing data in both places, so you can seamlessly switch over should something go wrong with one of the clusters. So replication is a feature that people, our application users, would primarily use to build BCP capabilities. So that's one. The second is we would copy a subset of very large data sets so that people can actually quickly query, not generate cross data center traffic, which, as I said, can be expensive and slow. The queries can be slow. So you can do faster queries locally in the same data center on the same network backplane as we described. So that's the second case. And then archival, a lot of the archival we do beyond the retention period on HDFS itself is governance, sort of compliance needed. So we use tape systems extensively for archival. Some of our Hadoop clusters themselves sort of act as the archival or historical data warehouses. And then beyond a certain point, for compliance reasons, we would put that on tape.
Hi, very good talk. Quick question. You touched upon upgrading the Hadoop stack in your last slide. I was curious, like, how often do your upgrades, and what are the things you're careful about when you do them?
So as I said, we're running upgrades every day. Everything is in flux. Softwares are being rolled out either for core Hadoop itself constantly or across our stack components constantly. Particularly the client-side things like Pig and Hive, it's really easy. I mean, we would upgrade like 18, 20 clusters in a day, 2 days. And then core Hadoop rolls out probably across a period of a month or two as we find issues and fix them. But upgrades are very frequent, multiple times a day sometimes. We are out of time, so if you have more questions, you could come to Yahoo booth and we'll address them. Sorry.